Good morning, everyone. I am N.S. Chandan Shri, Assistant Professor in Department of Civil Engineering in M.S. Ramaiah University of Applied Sciences. In today's session, we will talk about the plotting of the traverse, balancing the traverse, and finding the closing error and how do we correct that closing error. So these are the things that we'll be concentrating on in today's class. So to start with, when we conduct the survey, so this can be plotted in number of ways. So the generally there are two methods which can be used for plotting the survey. One is using angles and the distance method. So angles are the bearings that by bearings of a line that is measured in the traverse survey, and the distance is measured with the help of either chain or tape. So in this angle and distance method, we would need certain we could follow certain methods or certain uh, procedures to certain tools to plot the traverse. One being, we can use the protractor to mark the angles. We can use the method of chords, or we can even use the method of tangents of an by the tangents of an angles. Now that is about marking the angles. Second thing is marking the distance. So now distance, what we do is we scale down to a required value, and that scale is used, and that length is used to plot in the map. Second method is by the coordinate method. So in this coordinate method, the survey stations are plotted by calculating their coordinates. And this method is by far the most practical and accurate one for plotting the traverse. And when compared to other systems, we get more of horizontal control in this system. Then one of the major advantage of this system is elimination of the closing error. So we learn about the closing error in the further in this session, future in this session. We can detect and eliminate the closing error in this coordinate system. Now let us understand what this coordinate system is. This is called as consecutive coordinate system, wherein the entire area to be surveyed is divided into, or it is seen in such a way that the entire area is represented in the coordinate system. So when just like the other coordinate system, here also we have a 0 0 point, which is the intersection of north south and east west point. So four directions meet at a point, and that is said to have the coordinates of 0 comma 0. Now let us consider this line OA, and this OA can be represented in coordinate system using two parameters. One is latitude of the line and the other one is the departure of the line. So latitude of the line is nothing but the projection of the line on north south axis. Departure of the line is nothing but the projection of the line on east west axis. Now this latitude of the line can be found out by this formula, that is L cos theta. L is the length of the line measured using chain or tape. Theta is always the angle that is measured from the principal axis, that is, or the principal direction, or we can even call as primary direction, that is north south direction. So if the value is in third quadrant, then we measured with respect to south. If it is measured, if it is in northwest quadrant, again it is measured with respect to north. Similarly, the departure of a line can be found out by using this formula, that is D is equal to L sin theta. So L sin theta, so it's a simple trigonometry that is being used here. So L sin theta, or the departure, is the projection of the line on the east west or the x axis. Now we will see the sign conventions for these directions. If the line lies in northeast quadrant, then always the north will have the positive sign, south will have the negative sign. So negative north is nothing but south, east will have the positive sign, west will have the negative sign. So negative east is nothing but west, negative south, negative north is nothing but south. So that is what we have to remember. And these are called as northings, southings, eastings and westings of a given line. Now, if for example, now let us consider this line OB. Now for the line OB, which is in third quadrant, here as I told you, the angle is always measured with respect to the principal axis, that is north south direction. So it is measured from the south here, theta, and this distance is L. So the projection, the latitude of this line is projection of the line on north south axis, that is this is the latitude of the line, L into cos of theta, and departure is the projection of the line on east west axis, and that can be calculated using the formula L sin theta. So similarly here, now what sign will these latitude and departure have? Because they are both in south and west, they are in south and west quadrant, both latitude and departure will have negative sign. Now let us understand by solving one problem. First one, the question is what is written in red. Only this thing will be written in the, this is the question. So line is given and the length of the line measured is given in meters, and the whole circle bearings of the lines are given. So maybe they have used prismatic compass to measure the bearings of the line. So the answers that is obtained is in whole circle bearing system. Now, as soon as we get this data, the question here is to find out the latitude and departure of these lines AB, BC, CD and DE. So, we can find out the latitude and departure. Before that, we have to find out, this is a formula, right? L cos theta and L sin theta. Before everything, we have to find out the value of theta. Now, what did I tell? Theta is the angle measured from the north or the south. That means it is nothing but you can convert this whole circle bearings into reduced bearings, or also called as quadrantal bearings. So here 32 degrees 12 minutes becomes north, 32 degrees 12 minutes east. Then 137 degrees 36 minutes means it is in it is less than 180 degrees, so it is in second quadrant, that is southeast quadrant. So the quadrant are mentioned here, and then 180 degrees minus of 138 degrees 36 minutes will give us this value, 41 degree 24 minute. Next is third line CD. Now CD, the whole circle bearing is 202 degrees 24 minutes. So 202 degree 24 minutes comes in third quadrant, that is southwest quadrant. So quadrant name is mentioned here. So what is the theta from the south? It is 202 degree 24 minutes minus 180 degree will give us 22 degrees 24 minutes. Similarly, for the line DE, the whole circle bearing of the line is 292 degrees, which comes in fourth quadrant, that is northwest quadrant. In that case, the theta can be found out by 360 degrees minus 292 degrees will get 68 degrees. Now, once we get the value of the reduced bearing, now it is easier for us to calculate the latitude and the departure value. So the latitude value, one sample calculation is done here. For the line AB, the latitude value is equal to L cos theta. So always the latitude is calculated using this formula only, L cos theta. So L is the length of the line. Length of the line AB is 232 meters into cos theta. Theta is always measured from the north or the south. For this line it is north. So we don't have south here. You cannot have a quadrant like north south quadrant. It is northeast or southeast or southwest or northwest. So the theta value is 32 degree 12 minutes. So when we did that, we got the answer as 196.32 meters. Now, because this lies in the northeast quadrant, both latitude and departure will have positive sign. In the second example, as this lies in the line BC, it lies in southeast quadrant. Now what happens? Latitude value is negative and the departure value is positive. Similarly, line CD lies in southwest quadrant. Both latitude and departure are negative. Next is line DE. There it lies in northwest quadrant. So latitude value is positive, departure value is negative. So here the departure for the first line AB is equal to, again, L sin theta. L is 232 into sine of 32 degrees 12 minutes. We will get the answer as 123 degrees 63 minutes. Now that is about how we calculate the latitude and the departure for any given line of any length and whole circle bearing. If it is given, we can calculate. Now next comes the topic of closing error. What does this closing error mean? Now let us consider we have a traverse of we have done a closed traverse starting from A and we have done the ended the survey at A only. So the traverse goes like A, B, C, D, E, again comes back to A. Now what happens in the field? What we are doing, we are only taking the readings from the field, and when we start plotting it once we come back to the office. So this plotting, while plotting, what happens is there will the line that is marked here is marked in blue here is indicative of the error. So technically what should have happened, this point A1 and A should have been the same on the paper, but there exists some error. So that error is called as closing error, and it can be quantified using this formula, that is under the root the whole square of summation of all the latitude. Summation capital L is nothing but summation of all the latitude, and summation D means the summation of all the departure values square under the root. And the direction of the closing error, now to find out the direction of this closing error, we can use the formula tan theta is equal to sigma D by sigma L. Ultimately theta is equal to tan inverse of sigma D divided by sigma L. Now this is all about the direction and the magnitude of the closing error. Now we will talk about balancing the traverse. Now balancing the traverse means we have to eliminate this closing error and we have to find out the latitude and the departure correction for. Now if the error exists here, that means if there was no error in latitude or departure, then this value would be 0. This also would be 0. Then this entire thing would be 0. When the closing error is 0, that means A dash and A are the same point. Then there is no point in balancing the traverse. But here we balance the traverse using two methods. One is, these are two famous methods. One is Bowditch's rule. Bowditch's rule or Bowditch's method. Next one is transit rule or transit method. So what do we do in this two method? In the Bowditch's rule, correction in latitude or departure is given by total error in latitude or departure multiplied by length of that side divided by perimeter of the traverse. Now this is the formula that is used in the calculation of the correction for latitude or departure using Bowditch's rule. So correction for latitude is equal to total error in latitude multiplied by length of that side divided by the perimeter of the traverse. So therefore the correction in departure is equal to total error in departure. Here if you are calculating for the departure, you have to calculate you have to put the value of departure here into length of that side divided by the perimeter of the traverse. Now let us see how to balance the traverse using transit rule. Again, the correction in latitude in the brackets or departure is equal to, we'll write here, is equal to total error in latitude or departure multiplied by length of that, sorry, here it is, instead of length of that side it is latitude or departure of that line divided by arithmetic sum of latitudes or departure. So now these are the formulas by which we calculate the uh, total error in or which we use in Bowditch's rule and the transit rule. So now we will solve one problem through which we will understand the application of Bowditch's rule and the transit rule. First is Bowditch's rule. So in Baudi's rule, the question will be calculate the latitude comma departure closing error and adjust the traverse by Baudi's rule. And a table will be given here. So the table says okay. Line, length of the line in meters. Then we have whole circle bearing values. Then we have reduced bearing values. So first we'll write down the question. The line is AB. Length of the line is 89.31 meters. Whole circle bearing is 45 degrees, 10 minutes. Next is line BC. For the line BC, the length is 219.76. This is 72 degrees 05 minutes. 72 degrees 5 minutes. Next is line CD. The length of the line is 151.18 meters and the whole circle bearing value is 161 degrees 52 minutes. Next line is DE. The length of the line is 159.10 meters and the whole circle bearing is 228 degrees 43 minutes. Next is EA. Last line. The length of the line is 232.26 meters and the bearing is 300 degrees 42 minutes. Now this is the question that is given to us. So first step here is to find out the reduced bearing of these lines. So now here we are converting from whole circle bearings to the quadrantal bearing. So this line 45 degrees 10 minutes can be directly written as north 45 degrees 10 minutes east. Next, for the next line, it is 72 degrees 5 minutes. Again, it is in northeast quadrant. So, north 72 degrees 5 minutes east. This line 161 degrees 52 minutes is in southeast quadrant. So, when you compute, it is south 18 degrees 8 minutes east. Next line DE, it is in southwest quadrant. So south 48 degrees 43 minutes west. And the last line is north 59 degrees 18 minutes west. So now we have calculated the reduced bearing of the line. Once we calculate the reduced bearing of the line, our next step is to calculate computed consecutive coordinates So computed coordinates are latitude and departure. So latitude is always calculated using L cos theta, departure is calculated using L sin theta. So if we see here, both are positive in this case. So by applying L cos theta means L is the length of the line, that is 89.31 meters. So value of L latitude for the line AB is 62.96 7. Next, the departure is L sin theta. When you substitute and calculate, this will be 63.335. For the line BC, the length of the line is 219.76 and theta is 72 degrees 5 minutes. So again it is in northeast quadrant, so both are positive. So L cos theta is the latitude value, L is 219.76 multiplied by cos of 72 degrees 5 minutes, value of L is 67.607. So 67.607 meters. Here it is 209.102. And all these values are in meters because length value is in meters. For the third line CD, now latitude is in south. South means latitude has negative value, departure value is in east, so it is positive. So if you want to write the sign, we can mention here. Next, so for the line CD, the latitude value is 143.671. Departure value is 47.051. 47.051. For the next line DE, the latitude value is 104.971 meters. It is in south. Again, departure is also, it will have negative sign because it is in west. So L sin theta, when we do, we get the answer as 119.556. Last line, as the latitude is in north, it is positive, departure is in west, it is negative. So the value of latitude is 118.585. So 118.578, and this value is minus 199.709. So now what we have done till here is we have calculated the latitude and departure of this line. So computed value. Now our question says calculate the correct latitude and departure and adjust the traverse. So before that we have to check whether this has some error or not. Is there any error is there any closing error? So for that what we will do is find out the sigma L value and sigma D value. Now what is this sigma L and sigma D? Sigma L is summation of all the values from here to here, that is plus 62.967 plus 67.607 plus minus 143.671 minus 104.971 plus 118.8578. So answer you will be getting as plus 0.508. Similarly, when we do the same thing to the departure, so here 63.335 plus 209.102, 47.051 minus 119.556 minus 199.709. When we do, we get the answer as plus 0.223. Now in this, if instead of getting these values, if we had got 0 here, we would directly tell that there is no error and the traverse is perfectly fine. Now because these errors exist here, we have to calculate the corrections. Now these are the values of the errors. Error has positive sign, the correction will have negative sign. So we have to find out the corrections for latitude and departure. Next column here will be corrections. Correction to latitude and correction to departure. So now here we are using Bowditch's rule. So in what does the Bowditch's rule say? Bowditch's rule says that correction for latitude or correction for the departure so according to Bowditch's rule, correction for latitude is equal to summation of or total error in the latitude multiplied by length of that line divided by the summation of divided by the perimeter, that is sigma small l. Now in this problem sigma l is 0.50 0.508 multiplied by length of the line, first line we are finding out the correction for latitude. We have to find out the correction for latitude and departure for each line. So for the first line AB, we are going to find out the total value here. So now length of the line is 800 length of the line AB is 89.31. So this is 89.31 and denominator says perimeter of the traverse. Perimeter can be obtained by adding all the values of the length of the line. So when you add all these values from 89.31 to 232.26, we will get the value of summation small l, that is the perimeter, which is equals to 851.61 meters. So this value becomes 851.61 meters. So the answer that you will be getting is 0.0532 meters. Now what sign will we use here? So we have to check this value, that is sigma L value. If it has positive, the correction, if the error is positive here, the correction will have negative sign. Similarly, correction for departure for the line AB is given by total error in departure multiplied by the length of that line divided by the perimeter of the traverse. So that is how we calculate the error using Bowdy's rule. So total error in departure is how much? 0.223 multiplied by length of the line AB remains same, that is 89.31, divided by the perimeter 851.61 meters. So the departure value is 0.0233 meters. Again, here again we have to check the sign of the departure. So in this case, the sign of the error of the departure is positive, so the sign of the correction is negative. So now what we will do, we will write that I have done only one sample calculation. Similarly, we have to calculate for the all the other latitudes and departure. So the correction for latitude for line AB is minus 0.0532. Here it is minus 0.0233. For the line BC, it is minus 0.131. For the next line, it is minus 0.0575. Next is minus 0.090. Here it is minus 0.0395. Next line is minus 0.0949, and this is minus 0.0416. Next is minus 0.1385, and this is minus 0.0608. Now to check whether the corrections that you have calculated is correct or wrong, we have to do the summation. Now summation value of correction, that is CL, is equal to, when you do it, you will get minus 0.508. Here you will get summation value of correction for departure is equal to minus 0.223. So from this example we can know that here the errors and magnitude are same in magnitude, errors and corrections are same in magnitude and they differ by the sign. Now we have found out the corrections. Now last column is corrected consecutive coordinates. So again, latitude and departure. So again I will show you one sample calculation. So now this is the computed value of the latitude and this is the correction for the latitude. So the corrected consecutive coordinate, the corrected latitude for the line AB is 62.967 minus 0.0532. That will give us 62.9138. Next, here departure is 63 point, departure of that line minus the correction here. By chance, if the correction had positive values, whatever the sign the correction has, you have to add or subtract it. So when we do that, we will get these values. That is, for the line AB, we will get 62.9138. Next, here for the line BC, BC will get 67.474. Next, for the line CD, we will get minus 143.761. Next is minus 105.0659. Next line is minus 118.4395. So when you add all these things for the latitude, sigma L value you will be getting as, for the corrected one, you will be getting as 0.0004, which is approximately equals to 0. That means it is understood that you have eliminated the error. Similarly, in the departure, it is for the line AB 63.3117. For the line BC, it is 209.0445. Next line CD, it is 47.0115. Next line is minus 119.5976. Next line is minus 199.769. Again, we can calculate the error here. So when we do the summation, sigma D is equal to 0.0003, which is approximately equal to 0. So by this method, we can tell that we have balanced the traverse. Now one thing that we have to still calculate in this is the calculation of the closing error. So till now we haven't calculated the closing error. Closing error is equal to the formula says sigma whole L whole square plus sigma D whole square under the root. Now sigma L and D value are these values, error values, that is sigma L is 0.508, sigma D is 0.223. Substitute those values here. So that is under the root sigma L is 0.0 0.508 whole square plus sigma D is 0.223 whole square under the root. So closing error is equal to 0.5547 meters. So this is closing error magnitude. Now the direction of the closing error So the direction of the closing error is equal to tan theta, which is equal to sigma D divided by sigma L. So sigma D divided by sigma L means here we will be getting the answer as 0.223 divided by 0.508. So theta is equal to tan inverse of 0.223 divided by 0.508. So theta value will be 23 degrees 42 minutes. So here as all the values here the theta is in the answer for the theta will be in whole circle bearing system. So this is about Bowditch rule, and this is how we calculate the balance the traverse using Bowditch rule. Now same problem if we have to do it in using transit rule, then these columns will remain same, that is line length of the line, whole circle bearing, reduced bearing is also same. After that calculation of latitude and departure is also same. Now whatever is being displayed in the page now, that much of it is same. So once you find out that, we will calculate the instead of calculating these values, sigma L and sigma D value, along with that we will also calculate one more thing, arithmetic sum of latitude, arithmetic sum of departure. Arithmetic sum of latitude means we should not consider the sign, we just have to go on adding all these numbers, that is 62.967 plus 67.607 plus 143.671 plus 104.971 plus 118.578. So like this we have to go on adding it. Once we add, we will get the arithmetic sum. So once the arithmetic sum is got for both latitude and departure, the correction can be applied using the following formula. So we'll solve one more problem using transit rule. So now this is the second method. So here also the question remains the same, that is calculate the latitude, the departure, closing error and balance the traverse using transit rule. So we'll take one more question. Line, length of the line, then whole circle bearing reading, then reduced bearing reading. So these are the things given in the question. So question is for the line AB, now for the same question we will do length of the line is 89.31, whole circle bearing is 45 degrees 10 minutes. As we have done earlier, I am not explaining it in detail. Line AB, the same thing I am writing here. Line AB, line BC is 219.76 and whole circle bearing is 72 degrees 05 minutes. Then line CD, it is 151.18 meters and here it is 161 degrees 52 minutes. Next line DE is equal to 159.10 meters and this is 228 degrees 43 minutes. Next is line EA. For the line EA, the length is 232.26 and this is 300 degrees 42 minutes. Once we get the whole circle bearing of these lines, we can calculate the quadrantal bearing or the reduced bearing of these lines. So this is north 45 degrees 10 minutes. Next here it is north 72 degrees 5 minutes east. Next here it is south 18 degrees 8 minutes east. Next is south 48 degrees 43 minutes west. Then the last line is north 59 degrees 18 minutes west. So we have calculated the reduced bearing. After calculating the reduced bearing, the next step is Okay, sorry for the inconvenience. Once the reduced bearing is calculated, next step is to calculate the latitude and the departure. It's like the same problem. So this also I am writing it directly. Consecutive coordinates, latitude and departure. So calculated value is 62.967. Here it is 67.605. Next is minus 143.671. Next is minus 104.971. Last line is 118.578. Next, here for the departure values, it is 63.335. Next is 209.102. Next is 47.051. Next is minus 119.556, minus 199.709. So this is the calculated value. Now the the difference between those two problems will start here. Now what were we doing in the Bowditch rule? We would calculate the value of sigma L and sigma D. Here also we will calculate the value of sigma D and sigma L. Sigma L value is 0. That is plus 0.508. Here it is plus 0.223. Now along with this value we will calculate the arithmetic sum. We will name that as L subscript T. Here it is D subscript T. Arithmetic sum, that means we have to add all these numbers without considering the sign of it. So here we will get the answer as 497.792. Here it is same thing we have to do with the departure. Here it is 638.753. So now we have calculated the arithmetic sum of latitudes and departure. So now I will tell you how to find out the correction. Next step here is finding out the correction. So next column is correction. Again latitude correction, departure correction. So one sample calculation I'll show you here. So correction for latitude is equal to, the formula says total error in latitude or departure, that is sigma L multiplied by latitude of that particular line divided by the arithmetic sum. So for the line AB, sigma L is 0.508, this remains same, multiplied by latitude of that line AB, that is 62.967 divided by arithmetic sum is 497.792. So correction for latitude is equal to 0.0642 meters. So correction for latitude for the line, this is for the line AB. Similarly, correction for departure. Correction for departure is given by same formula, that is total error in departure multiplied by departure of that line divided by arithmetic sum of all the departure. So the total error in departure is 0.223 multiplied by departure of line AB, here it is 63.335 divided by total arithmetic sum of all the departure, that is 638.753. So the departure of this line AB, correction for the departure of this line AB is 0.0221 meters. So now what is the sign of the correction? We have to check the sign of the error. Error is positive, so all the corrections will have negative sign. So I'll directly write the value here. Other correction for latitude and departure should be done as shown now. 0.0642. Correction for departure is minus 0.0211. This is 221. Next, this is minus 0.0689. For the line BC, the departure correction is minus 0.073. Here it is minus 0.1466. Here it is minus 0.0164. Next, minus 0.1071. This is minus 0.0417. And this is minus 0.1255. Here it is minus 0.0694. And the last column is same as above. That is, we will find out the corrected coordinates. Last one is corrected consecutive coordinates. That is for latitude and for departure. So here the principle is same, only the procedure for finding out the correction is different. So here we find out the latitude by latitude of line AB plus or minus the correction along with the sign. So this value here becomes 62.9028 and this is 63.3129 and this is 67.5361 and this is 209.029. Next, this is minus 143.8176 and this is 47.0346. Next, here it is minus 105.0781 and this is minus 119.5977. Last line is 118.4525 and this is minus 199.7784. So when we add all these things, sigma L is 0.0043, which is approximately equals to 0. Here again sigma D is equal to, when we add all these things, we will get 0.0004, which is approximately equal to 0. So this is how we balance the traverse using transit rule and the Bowditch rule. Thank you.